Okay, so welcome back. So in this video we're going to talk about finding arc length when we have something like this. Okay, so now if we take this example, we want the formula for arc length. So remember, the formula for arc length is going to be the integral from a to b of the square root of 1 plus the derivative f prime of x, quantity squared, dx. Now, in this case, the derivative dy dx is equal to 2x, which then gives us, in this case, we're going from this interval, we're going to get the integral from 0 to a half of the square root of 1 plus 2x squared dx. Okay? Now, the issue is we've got 2x in here. Here it's x squared. We don't have, our coefficient is 1. Here we have 2. So, how do we handle that? Well, we need to get tangent here. We need to get, remember, our general substitution in this case is x equals a, right? Why do we have a here? Because we're going to get a squared. We want an a squared here so that we can factor it out, because the goal is we need to get 1 plus tangent squared theta. That's the goal, right? So we could use the property to simplify and get rid of the radical, right? That's what we need. So we need the a there for that reason. And then obviously the tangent obviously needs to be there for the same reason. Okay? But now we've got this 2. Well, we'll just make 2x equal to that. Okay? Nothing wrong with doing that. So we can make 2x equal to this. We just need to make this substitution equal to a times theta. Now in this case, a is just 1. Okay? So no big deal. And then all we're going to do is divide by, now here's the thing. I'm not sure why it matters whether you use x, because it's going to cancel out anyway. If I put 2x equals tangent x, we'll get tangent x here. Oh, I know why. Because of the dx. Okay, so we'll divide both sides by 2 and make this into x equal to 1/2. Tangent theta. And then dx equals 1/2 secant squared theta d theta. And now, because we're dealing with a definite integral, we're going to have to also change the limits of integration. So now, when x is 0, what does theta have to be in order to get x equal to 0? Well, 0, because the tangent of 0 is 0. Okay? So that's going to stay the same. Now, to get a half here, well, there's a half. So that means tangent theta would have to be 1. Well, the only angle that will give us a value, a tangent of 1, is a 45-degree angle, which is just going to be 1 over 1, right? So again, look at your unit triangle, right? A 45-degree angle, 1, 1, square root of 2. Right, so the tangent of a 45-degree angle will give us 1. So that's pi over 4. Okay, so we're going to go to pi over 4. Oops, we didn't substitute yet. So let's go to pi. We're going to go to from pi over 4. So let's write this as 0 to pi over 4. Now let's do our substitution. 1 plus well, this is going to be 4x squared, so let's change that. So now that we know what our substitution is going to be, let's simplify that. So this is going to be 4x squared, right? So now x is going to be 1/2 tangent theta, so let's see what happens. So we're going to have 4 times 1/2 tangent theta squared, and then dx is going to be 1/2 d theta, right? So now I'm going to pull the half out here. So this is going to equal 1/2 0 to pi over 4 of this. Now I'm going to distribute the 2, right? So this is going to be 1/4 tangent squared. So this is going to be 1 plus 4 times 1/4 tangent squared theta, and the half I pulled out, so this is just going to be secant squared theta d theta, okay? And so now we get 0 to pi over 4. Now things are going to simplify. So this cancels with this, and we get our 1 plus tangent squared theta, which is what we want, right? Okay, now this becomes secant squared theta squared underneath 1 pi over 4. The square root of secant squared theta times secant squared theta d theta. Now, because secant is positive over this interval, we can undo this and just without the absolute value signs, right? So it's just going to be secant theta. So we're going to get the integral of from 0 to pi over 4, and we're going to get secant theta times secant squared theta d theta, and of course we get our result from 0 to pi of secant cubed theta d theta. Now, I'm not going to do this whole thing. We already did this in a previous video. So you have to do integration by parts. Remember, you're going to shave off one of the secants, and then you're going to do integration by parts. And, well, in fact, you're going to have to do integration by parts twice, and then you're going to end up with the same thing. You're going to end up with getting the same thing again, and then you're going to have to add it to both sides and divide by 2 and do that stuff. I'm not going to do that here, okay? So this gives you, this is going to result in, oh boy, I missed the 1/2. I dropped the 1/2 along the way. I dropped the 1/2. Bad. Can't drop the 1/2. Okay, so now I get 1/2, and this is going to end up being the natural log of the absolute value of Oh, I think that's subtract. No, I was right. Yeah, that's right. And then this is evaluated from 0 to pi over 4. Now, at this point, it's just plug and chug. Okay? Now, at 0, now this is where things get a little easy because tangent of 0 is 0. So this will go to 0, and this is going to be 0, right? So at 0, you get, oh, and secant. So secant is 1 over cosine, right? And cosine of 0 is 1. And the natural log of 1 is 0. So at 0, this whole thing is going to be 0. Okay, so that makes things easy. Now, at pi over 4, well, pi over 4, this is going to be 1. This is going to be 1. So here we get half of secant theta. So again, 1 over cosine theta. So what is cosine of a 45-degree angle? Well, it's 1 over the square root of 2. Okay? Or if you rationalize it, it's the square root of 2 over 2. Right? Which is what you always want to do. So never leave it as 1 over square root of 2. Get the radical out of the denominator. So it becomes square root of 2 over 2 is what you want. Okay? So what does this become then? Well, this is going to become 1/2 the natural log. Okay, so this is going to be square root of 2 over 2. This is going to be plus 1. Oh, I'm sorry, no. Remember when I said cosine? I'm sorry, this is secant. I said 1 over cosine. And I said it right, but I didn't say it fully. So cosine is 1 over the square root of 2, but then I forgot we're dealing with secant, so it's the reciprocal of that. So it's square root of 2 over 1. So this just becomes a square root of 2. And this becomes a square root of 2. So this becomes the natural log of square root of 2 plus 1. And we could drop the absolute value signs because this is obviously positive. And this is going to be 1/2, so plus 1/2 times the square root of 2. And so the final answer becomes 1/2 natural log, the natural log of square root of 2 plus 1 plus 1/4 the square root of 2, or square root of 2 over 4. And I think that's right. Let me just make sure. Okay, so this is 0, this is 0, this is 1, which is a natural log, so it's 0, this is just 0. And then at pi over 4, we get 1 over cosine. Cosine of a 45 degree angle is 1 over the square root of 2, so secant, 1 over that is secant, which is square root of 2. So this is going to be square root of 2. This is going to be 1, so square root of 2 plus 1. So you get the natural log of that. And then this is secant theta times, so this is going to be 1. So this is just going to be the square root of 2 here as well. And is that what I end up having? So natural log okay, so I get square root of 2 plus 1 plus 1/2 square root of 2 yeah, that's right. Okay, let me know if you have any questions.